Okay, so let's keep working where we left off. We know all of the sides of a triangle, so we're going to use law of cosines, and we're going to use it to solve for the missing angle. So these are the questions that we don't like because it takes multiple steps in our calculator to solve it. So the first thing that we would do to solve this is I would square this, square that, and then move them all over. So instead of doing that out in a bunch of steps, I can kind of just do it all in one in my calculator. So 18.6 squared minus, now I'm going to subtract over both of those terms all at the same time, minus 15.8 squared plus 24.3 squared. I'm going to subtract that whole term all at once. Hit enter. Okay, so I now have negative 494.7 or 0.17 is equal to negative 2 times 15.8 times 24.3 cosine of x. And I want to get cosine of x by itself, so I want to divide by everything that I just multiplied out in front of it. So I'm going to divide that answer by negative 2. And remember, it's really important that you put this in parentheses, because if you don't, then the calculator thinks that you want to take 494.17 and divide it by negative 2 and then keep multiplying. So you need to put that in parentheses. Times 24.3. Hit enter. So cosine of x is equal to negative 6 or negative 0.64355. I don't really care what cosine of x is. I want to know what angle x is. So I'm going to do second cosine, second answer to figure out what the angle is. And that is 49.94 degrees. And it said that it wants it to the nearest tenth of a degree. Whoops, sorry, Parker. Nearest tenth of a degree. So this angle is 49.9. But remember, that's not what the question was asking us for. It actually wanted to know what this angle was equal to. So now that I figured out this, I know that that angle and that angle add up to 180. So I can do 180 minus 49.9. And I know that this angle, which was what I wanted originally, is 130.1 degrees. That is my final answer. Okay? So you just have to be careful about what you're actually solving for, because we do kind of say, hey, forget about this one for a second, let's solve this. And then you have to remember at the end of the problem to go back and solve for that one. Okay? Hopefully that's not too bad. We have 2 more questions, and then that is it for this chapter, okay? So I'm just going to go through these some more with you. Alright, a resultant force of 162 pounds. Okay, so parallelogram, resultant force, and the resultant force is 162 pounds. These questions, they're going to say 162 pounds. Some of them will say newtons. Some of them will say, I think it's normally just pounds and newtons, but really it's just the magnitude or the length of that line, okay? So just don't get confused by that. A resultant force of 162 pounds must be exerted to move a refrigerator. If the 2 applied forces act on the refrigerator at angles of 43.6 degrees and 38.7 degrees. So it's saying that this angle is 43.6 because that's the bigger one. And this angle right here is 38.7. Find the magnitude of each of the 2 applied forces to the nearest tenth of a pound. So it wants us to solve for both of those. It wants us to solve for x, and it wants to solve for y. Okay, I'm glad that it did this because we haven't seen a question like this before. Let me just remind you of a couple other things that have to do with parallelograms. I'm sure that you remember this from geometry. So if this line on the top is parallel to that line on the bottom, and this line cuts it in half, then remember it's what we call alternate interior angles. So the 38.7 degrees right here is actually equal to this angle as well. So that one up there is also 38.7 degrees. And then the same thing goes if you kind of like tilt your head and look at it like this. This angle, or that line, is parallel to that line. So alternate interior angles say that this angle of 43.6 is also equal to this angle of 43.6 as well. So that's another kind of cool thing that we know about a parallelogram. So if I already know that this is 38.7 degrees, and due to alternate interior angles, I also know that this is 43.6 degrees, then I have two of the angles of a triangle. I know that this is 162. I know that if that's side y, then this is side y as well. And I need to solve for each of those. Now this looks like it's going to be a question where we deal with law of sines. Because with law of sines, you take the sine of A divided by the side across from it, and the side of B divided by the sine across from it. But if we did that right now, we would have two unknown variables. So we can't do that yet. But what I do know is that this is 162 degrees. They wouldn't have given me that information unless I needed to use it somehow. So if that's 162 degrees, how about we try to figure out what this angle is equal to? And then we could use, sine of this over that, and we can use that in our law of sines formula. So luckily, because I already know what two of the angles of that triangle are, I can figure out that one really easy. So let me clear this out. 38.7 plus 43.6, that gives me a total of 82.3. So that means that the remaining angle of the triangle is 97.7 degrees. So we haven't used trig at all yet. We've actually used geometry more often than trig so far. But now what we're going to do is use the law of sines right here. Okay, so I'm going to use this to figure out what x is and then to figure out what y is. So let's see here. I'm going to do sine of 97.7 degrees divided by the angle, or the side across from it, which is 162, is equal to, let's solve for x first. So the sine of 43.6 divided by x. Okay, so that's how I'm going to solve for x. And you know what? Why don't I just write it out while we're doing it, because we might as well. So to solve for y, I'm going to do sine of 97.7 over 162 is equal to the sine of, I'm looking for y, so the angle across from it is sine of 38.7 over y. So that's how I'm going to solve for those two angles. And then we've done this a lot so far, so it's actually pretty easy to solve for these angles. So if you would like to, John, you could always write this out. You can write out the cross multiplication if you need to, but you don't have to at this point. All we need to see is the answer. So what I'm going to do is 162 times the sine of 38.7 hit enter, and then I would do sine of 97.7 times y, and then I would have to divide. So divide by sine of 97.7. Hit enter, and y is 102.2109, and it wants it to the nearest tenth of a pound, so y is equal to 102.2. Okay, So I figured out one of them already. Let's figure out what x is equal to. I'm going to cross multiply again. So this time, 162 times sine of 43.6. Hit enter, and then I'm going to divide by the sine of 97.7. Hit enter. So x is 112.734. So to the nearest tenth, x is 112.7. So that wasn't too bad. We figured out what those two sides were, and really that question was more heavily, focused on geometry than anything else. So we got one more question. Let's do it kind of fast, and then we will be done. So two forces act on a body, and we're dealing with forces, so I'm going to draw a parallelogram such that the resultant force is 73.4. The angles between the resultant and the applied forces, so the angles between the resultant force and that applied force and the resultant force and this applied force, measure 56 and 47. So if you take a look at our picture, this is the bigger angle right here, so this one's 56. And 47. Find to the nearest tenth of a pound the magnitude of the larger applied force. So what I told kids on the test, because we did have a question like this on the test, it said find the larger applied force. And the way that we have things labeled in our drawing, this should be the larger applied force right down here. However, I was kind of skeptical, because what if you set up something wrong and maybe this was the larger applied force? So what I told kids was, on the test, if it says find the larger or the smaller, I would just solve for both of the applied forces, and then, if you made a mistake, then you can fix it right then. Okay, so let's do that. It looks like we're going to solve this the same way that we did before. So if I know that this is 56 degrees, because of what I learned from geometry, I know that this is 56 degrees as well. And I know that if that is y, then this is y as well. And now I can just take a look at all the stuff that's in this smaller triangle. And I'm going to stop this right now and start another video for you.